Hey pre-calc students, today and this week we're going to take a little bit of a break and detour into something called sigma notation. So sigma notation is something that we use when we're talking about series. And in order to talk about series, let's refresh our memory real quick about what a sequence is. So remember, a sequence, you might remember from advanced algebra trig, is just a list of numbers. So, maybe 2, 4, 6, 8, 10 would be the numbers in a sequence. And it can continue on after that, or it can stop. That would be a finite sequence if it stopped, or an infinite sequence if it went on forever. So then a series is just the sum of a sequence. So 2 plus 4 plus 6 plus 8 plus 10 plus continuing on. And so there's actually two different types of series that we talk about. There's infinite series, where the terms go on forever, and then there's finite series, where we just might sum up just some of these terms. And so instead of just writing out every single thing that you would be summing up, every single term, since that gets kind of tedious, there's a way that we can index it so that we don't have to do that every single time, and that's where sigma notation comes in. So sigma notation starts with the Greek letter sigma, and so there's a number on the bottom, which is the first indexed value that it starts with. So n equals 1 or 0 are the ones that you find the most often, but you could start it anywhere with n equals whatever you like. And then the top number is the last indexed term. So I don't know, maybe 4 or something like that for a short one. And then the definition of the terms is right in here. So maybe n plus 2 or something like that. So what you would do to figure out what this sum is, or one thing you could do to figure out what the sum is you can go, okay, the first thing I plug in is 1, since I know n equals 1 is where we start. 1 plus 2 is 3. So that would be my first term. Second term, third term, fourth term, since we're only going up to 4. And then my second term would be 2 plus 2, which is 4. My third term would be 3 plus 2, which is 5. My fourth term would be 4 plus 2, which is 6. Okay. So this would be how I would find the sum of this series. So this is a finite series because this number is a finite number. To know if it's an infinite series would just be the same exact thing, except instead of a 4 up here, you would have the infinity symbol. That would tell you to continue adding up the terms forever and ever and ever and ever. Okay, so we have infinite and we have finite. And now some things that you might be asked to do regarding sigma notation. One thing you might be asked is, you might be given something like this and be asked how many terms are in this series. Well, this one's pretty easy. You're starting at 1 and you're going to 10. That means there's 10 terms. But what if you're not starting at 1? What if I'm starting at 7 instead and going from n equals 7 to 10? Well, you have, starting with 7, you have 7, 8, 9, and 10, right? That's 4 terms. But 10 minus 7 is not 4. You have to account for the endpoints. So if you can just subtract these two numbers, but then you have to add 1 to account for the endpoint. So 10 minus 7 is 3, plus 1 gives us 4. There would be 4 terms in this series. Okay, so that's one possible type of question that you could be asked. Another thing that you could be asked to do is you could be given a written out series, kind of like this. Like, let's say we had 4 plus 7 plus 10 plus 13 and plus ... And we want to write this in sigma notation. So first thing you would do, pick a starting point. I usually like to start with n equals 1. And since this is ... here at the end and it doesn't just end with one term, That tells you that the top is going to be infinity. Then we have to figure out how to define the series. So if this is my first term and n equals 1, and then we kind of have to start noticing what's going on in here. What's the difference between each of these? Is there a common difference? In this case, we're going up by 3 each time, right? Okay. So that difference that you're going up by each time, that's what you're multiplying n by. That's your common difference. And then to get it to start at the right place, if I plug in 1 here, well, 3 times 1 is 3. That's not quite in the right starting place. So I need to add 1 to it to get it into the starting place that I want. So it would be the sum of 3n plus 1 from n equals 1 to infinity. Okay, so that's an example of finding the sigma notation given the series. There's some common ways, so if that didn't seem super intuitive, that's okay. There are some common ones to watch out for, and this is one of them. So you might remember from advanced algebra talking about arithmetic and geometric series. So arithmetic is where we've got this common difference. It's going up by something each time. So it has a common difference. And then there's geometric. And that's where it's multiplied by something each time, and it has a common ratio. So for example, with arithmetic, we just did one that was arithmetic, but if we were doing another one, let's say we had, I don't know, 5 plus 9 plus 13 plus 17. If I wanted to write this in sigma notation, well, my common difference is what I'm going up by each time. So that would be 4. I'm adding 4 each time, right? So the way that I write it in sigma notation is I'm just going to start with n equals 1. And since there's 4 terms, I'm going to go from n equals 1 to 4. And we're going to start off with 4n because that's my common difference. So whatever your common difference is, that's what you multiply n by. And then in this case, since I'm starting at n equals 1, if I plug in 1, 4 times 1 is 4. To get it up to 5, since I want this to be my first term, I have to add 1 to it. So this, in sigma notation, would be this. And you can start it at different points if you want to. You just have to account for it within whatever you add or subtract from it. So if I wanted to start it at 0 or 5 or something like that instead, I can change the way I index it. I just have to change the top number to account for the amount of terms, and I would have to change this number. So starting at 1 or starting at 0 are typically the easiest ones to start at. Okay, the other common type of series is geometric. And geometric series have a common ratio. So for example, if we were doing 3 plus 9 plus 27, doing that series, our common ratio here is I'm multiplying by 3 each time. Okay, so that would be, I could continue it, I guess, 81, do one more at least. So if I'm multiplying by 3 each time there, the way we write a geometric series is very similar. And this one, since we have plus dot dot dot, is going to be infinite. And this one would be 3 to the n. So whatever the common ratio is, that's what goes in the base of your exponent. So in this case, it's 3 to the nth power, because each time I'm multiplying by 3 again and again and again. Okay, so that's a basic geometric series there. So those are some common ones that you might see. Let's see. So far we've covered infinite and versus finite. We've covered how many terms does it have. And now we've covered just very basic arithmetic and geometric, so that we can kind of start seeing some patterns if we are given a series written out and asked to put it into sigma notation. So that's all we're going to do for today. I'll probably put a little bit more next time on how to quickly sum arithmetic and geometric series. But other than that, if you have any questions, feel free to email me or come to office hours or comment below. And have a wonderful day.